Hello, student math community. So we are continuing the discussion of adding fractions. This video concerns adding fractions that have different denominators. And so you notice in my first example, we have 1 over 4 and 9 over 30. So I'm pretty sure you can see that those are different numbers. And so the way you add fractions, as you saw in the previous video, was when you have the common denominator, when the fractions are divided up in the same number of parts, you can just add the numerators. Well, we can't just go through and add tops and bottoms of this. We have to find a least common denominator. So if you have been doing some of the videos in the student math community, then you have encountered the video on finding least common factors. And so the least common denominator is just the not least common factor, least common multiple. You have found the video on least common multiples. And the least common denominator is just the least common multiple of all denominators. So for this video, I'm going to assume that you have watched that and you know how to find least common multiples. If that is not true, then I invite you to go back, stop this video, and go back and watch the video about least common multiples. I show two different methods, and I want you to be good at doing that. So between 4 and 30, the least common multiple is going to be 60. So what I'm going to do in my process is I am going to write the common denominator. And then I ask myself the following question. I want to know 4 times what gives me 60, and it's 4 times 15 gives me 60. And so I do the same thing in the numerator. That is my clue. And 1 times 15 is 15 over 60. So now I have a new fraction that has the common denominator. I do the same thing for the other fraction. 2 times 30 is 60, and that gives me the clue of what to do in my numerator. 9 times 2 is 18 over 60. And now I am ready to go ahead and finish up this problem and add up my numerators. So again, I got the common denominator, so 15 plus 18 is 33 over 60. And as with all problems, we make sure they are reduced. That's a 3, not a good-looking 3, but it's a 3. And so 3 goes into 33 11 times, 3 goes into 60 20 times, and that is our reduced fraction. Same thing happens in the second problem. I've got a 6 and a 15. Those are different. And so again, the common denominator, which is found by the least common multiple of both of those denominators, is 30. And so 6 times 5 is 30. And so that tells me that I multiply the top by 5, and that gives me 25 out of 30. 25 out of 30 is the same proportion as 5 out of 6. Okay, we're just changing the denominator so that I can add the fractions. For the second fraction, 15 times 2 is 30, so that gives me the clue that the numerator is 2 times 2 is 4. And now, once the denominator is the same, it's ready to combine. So 25. This is actually, I apologize, this is actually a subtraction problem. Okay, glad I caught that. So 25 minus 4 is equal to 21 out of 30. Again, we can reduce this. I can divide the top and the bottom by 3, and I get 7 out of 10 as the answer. So I'm going to advance the slide. I invite you to pause your video and try these 4 problems. Okay, welcome back. So for each of these problems, hopefully you found the least common denominator. So for the first problem, the least common denominator between 8 and 12 is 24. And again, if you've gone back and investigated the video, you know you can do that either by the listing method, which will work for most of these denominators, or the prime factorization method, which is quicker and works always. So 8 times 3 is 24, and so 5 times 3 gives me 15 out of 24. And then 12 times 2 is 24. 5 times 2 is 10 out of 24. Okay, we are ready at long last to add these fractions now that they are divided up into the same number of parts. 15 plus 10 is 25 out of 24. That doesn't reduce. You can make that a mixed number if you want. Mixed numbers are not reducing. They're just a different form of the same number. I prefer in algebra improper fractions to mixed numbers, so I am going to leave the fraction as an improper fraction. The next problem, I've got 7 out of 10 minus 1 out of 8, so the common denominator between 10 and 8 is 40. And this time we're subtracting. I'll be a little more careful with my signs this time. So again, 10 times 4 is 40, so my 7 times 4 is 28 in the top. 8 times 5 is 40, so I have 1 times 5, or 5, in the top. So now I have divided my fractions into the same number of parts. I have 28 minus 5 is 23 parts out of 40. That does not reduce. 23 is a prime number. We are done with that problem. The second to last problem on the screen, the common denominator between 11 and 5. Since they share no factors, the common denominator is easily found to be 55 just by multiplying those two things together. And so now I'm going to go through and I'm going to get my common denominator, or I've got it, so let's get my numerators. So 11 times 5 is 55, so 6 times 5 is 30. And then 5 times 11 is 55, so 3 times 11 is 33. And you notice I made that negative. That negative is important, so don't lose that. Always be super careful with your signs. So if you remember the rules for adding signed numbers, again, there's a video for that above in the student math community. When you have two numbers with different signs, you take the difference between the values. So the difference between 30 and the difference between that and 33 is 3 out of 55. And then the sign is the sign of the larger value, which is 33. So it's going to be negative. Does not reduce. We are done. The final problem. The common denominator between 21 and 6 is 42. We're subtracting this time, so here we go. And then 21 times 2 is 42, so the numerator is 16. 6 times 7 is 42, so we get 35. We are going to proceed by doing this subtraction by adding the opposite. So I'm going to make that 16 over 42 plus a negative 35 over 42. This is the same as the last problem. I'm adding two numbers that have different signs, so I take the difference between 16 and 35, which is 19, over 42. Sorry, that should be a 2, not a 9, so let's try to write that again. That's 42. And then the sign of the result is the sign of the larger, which is a negative. Does not reduce. We are done. Practice, practice, practice. You can avoid algebra problems by being good at arithmetic. I hope you do well.